So hello everyone, welcome to Algorithms tutorial. Today we are going to discuss about coin row problem, which is one of the important problem in dynamic programming. This class I am recording it using tablet, so there is a little bit handwriting issue. So if you won't understand the handwriting, please bear with me because I am using tablet to write the problem. Okay. Maybe the handwriting is not clear, so please bear with me. I'll try to write as much as neat as possible. Okay, right. So the problem, coin row problem, is, consider, suppose we have some coins arranged in a row such that, so the coins are arranged in a row like, so we have coin 1, coin 2, like this. The coins are arranged in a row such that, so the cost of coin 1 is C1, the cost of coin 2 is C2, like this. So each coin is having its own cost. Okay, so the problem here is, here we need to pick up the coin from left to right in such a way that if we pick one coin, we should not have to pick the adjacent coin, and when we pick all the coins, or when we pick the coins, the amount that we have to get is maximum amount. The amount should be maximum. So we have to get max amount when we pick the coin, and we have to pick the coin in such a way that if we pick one coin, for example, consider we picked coin 2, so it means we should not pick coin 1 as well as we should not pick coin 3, which is adjacent to this coin 2. Okay, this left side adjacent as well as right side adjacent. For suppose, for example, consider we have picked a coin n, that means we should not pick coin n minus 1, because there is no adjacent on the right side of coin n, because that's the last coin. So that means I should not pick coin n minus 1. Consider there is a coin n minus 1 which is adjacent to this n coin. I should not have to pick that coin, and after that we have to get a maximum amount from this. Okay, so this is called as coin row problem, and this is a maximization problem. As we know that maximization is nothing but it is optimization, and we already know that optimization problems can be solved by either dynamic programming or by using greedy method. Now in our coin row problem, we are using dynamic programming to find the maximum profit out of this coin. Okay, so we know that these coins are placed in the rows like first coin, second, third coin, fourth coin, like this. Up to n coins are placed, and its cost is already mentioned as C1, C2, C3, C4, and so on up to Cn. So last coin cost is Cn. Consider, so before 1, that means there is no coin. 0 coin means its cost is already 0. Okay. Now let us have the recurrence relation for this. Okay, maximization. So f of n is equal to, it is 0, that means the cost will be 0. This f of n represents the cost. Okay, cost of picking the coin. So 0, when it is 0, when I have not picked any coin, that is n equal to 0. N equal to 0 indicates I have not picked any coin, that means this one. So if no coin is picked, its cost is also 0. If I picked one coin, n equal to 1, n equal to 1 means this coin, first coin. So what's the cost involved for that? It is C1. The cost involved for that is C1. Suppose if I pick the coin which is greater than 1, that is n greater than 1, then the recurrence relation for this becomes, it is max of Cn plus f of n minus 2, Cn plus f of n minus 2, comma f of n minus 1. So it means out of these two terms, there are two terms here. One is Cn plus f of n minus 2, and another one is f of n minus 1. Out of this term, which one is maximum, that we are considering it as answer. Suppose consider if we got Cn as 4 and f of n minus 2 is as 2. then f of n minus 1 is 5. So out of this two, it is now 4 plus 2, that is 6, and this is 5. So out of this two, which is maximum? 6 is maximum, and that becomes the answer. So it is like this. Okay, right. So this is the recurrence relation for coin change problem. So let me erase this. Okay, so let us consider the fresh program for this. Uh, right. So I'll write it here one more time. So zeroth coin, first coin, second coin, third, fourth, like this. We have the coin up to n, and the cost of first coin. 0 means we have not picked anything. That means its cost is 0. The first coin cost, consider it as C1. Second coin is C2, like this, C3, C4, up to Cn. Okay. Now, so recurrence relation I also already written, but let me write it once again. So f of n, it gives the cost, okay, of the coin. The cost is 0 when if n is equal to 0. That means I have not picked any coin, this one. Then the cost is cost of one coin. That is, if I pick n equal to 1, first coin, the cost is C1. And if suppose I pick n is more than 1, that is n is greater than 1, then we get the recurrence relation as Cn plus f of n minus 2 comma f of n minus 1. So this is when n is greater than 1. Okay, right. So the meaning of this is very simple. You know that if we pick Cn is nothing but cost of n coin. That means if I pick this n coin, then what is this? If you pick Cn, that is nth coin, then you have to pick n minus 2 coin. That means you should not pick the adjacent coin. What is the adjacent coin of n? It is n minus 1. N minus 1, then cost will be C of n minus 1. So that means here you can see, if I picked Cn coin, that is n coin, I have not picked n minus 1 coin. I have directly picked n minus 2 coin, which is not adjacent to this n minus 1. Okay. Suppose if I picked n as well as n minus 2 coin, then if it is not maximum, if this two values, if I picked the last coin and last this coin, n minus 2 coin, adding together the cost is not maximum, then we have to check with the n minus 1 coin. For suppose, for example, consider n coin cost is 2 and n minus 2 cost is 2, and this n minus 1 coins cost is 5. Okay, so you know that once I pick this coin, adjacent coin should not be picked. That means if I pick 2, then I should not pick this coin, that is n minus 1 coin. I have to pick this coin. So if you add these two, that is 2 plus 2, then it is not maximum when I consider to n minus 1. Okay, it is not maximum. So that's why I should not pick this 2. I have to pick this n minus 1. So if you pick this n minus 1, you know that you should not pick n minus 2. You have to pick n minus 3. So the approach is like this. Okay, so if you pick n minus 1, you can't pick n also, and you can't pick n minus 2 also. So you have to pick n minus 3. So that means adjacent coin you should not pick. So please keep this in mind. So this is about the coin row problem. Let us have one example to see how this coin row problem works. Okay, so I'll erase this all and we'll start with the fresh one. Okay, let me erase this. Right. So we'll write the problem here. So the problem is like this. So we have index here. Index is nothing but it shows the coins. So we have 0th coin, first coin, second coin, 3, 4, 5 and 6. 6 coins are given and the assets are given. Assets are nothing but the cost of each coin. So 0th coin means I have not picked anything. Its cost is obviously 0. The coin number 1, its cost is 5. Coin number 2, its cost is 1. Coin number 3 is 2. This is 10. 6, 2. So now this is the given problem and I have to pick the coin in such a way that we should not pick the adjacent coin and we have to get the maximum value or maximum amount. So let us apply our coin row problem or the method. So here we are applying tabularization method for solving this problem. Okay, so you know that in dynamic programming we have two techniques. One is memoization and one more is tabularization. So let us apply this tabularization technique to solve this problem. Okay, we know that the cost of the first coin, that is 0th coin, is 0. So f of 0 equal to 0, and the cost of the first coin, that is f of 1, is equal to 5. So this is given here. So now let us calculate what's the cost of the second coin. Okay, so this is 0, this is 5. So let me calculate all this 2, 3 up to 6. Okay, right. So f of 2 is equal to, we know that this is greater than n. Here n value is 2, that is greater than 1. So for the n value greater than 1, we have the recurrence relation called as max of f of cost of the second coin C2 plus it is f of n minus 2. So that means here it is f of 2 minus 2 comma f of n minus 1. So here n is nothing but 2. So that means 2 minus 1. F of 2 minus 1. So this is nothing but max of. So what is cost? Second coin cost, it is asset. It is 1. Asset, this is nothing but asset only. So asset is 1 plus f of 2 minus 2 is nothing but f of 0. So what is the value of f of 0? Already it is known, it is 0 here. So it is 0, 1 plus 0, comma f of 2. F of 2 minus 1 is nothing but f of 1. What is the value of f of 1? F of 1, its value is 5. So this is equal to 5. So out of this 2, this is 1 plus 0, this is 5. Out of this 2, which is maximum? The maximum is 5. So that means the answer for f of 2 is 5. So this is 5. And how we got this 5? We got this 5 from f of 1. Okay, we got this 5 from f of 1. So please write it below this. So it is, we got this maximum value because of f of 1, because you can see here. So here it is 1 plus 0, this is 5, and 5 is nothing but it's a cost of f of 1. So that's why we got the maximum value. So it is 5. So 5 because it is f of 1. From f of 1 we got this value. So you have to mention it like this. Next we need to calculate f of 3. So f of 3 equal to, what will be the recurrence relation now? F of 3 equal to, it is max of, I will directly write here, max of C3 plus f of 1 comma f of 2. So I have directly applied the formula here and I have written here. So this is equal to max of, what is C3? It is 2 plus what is f1? It is 5 comma what is the cost we got for f2? It is 5. So this becomes 7 comma 5. So out of this 2, which is maximum? 7 is the maximum. So f3 cost is 7. And how we got this 7? We got this from f1, but it is not just from f1. We added cost 3 for f1. That means we got it from f1, but it is not from f1 only f1, it is from cos 3 also. That means this is the new value that we got. So I will mention it as f3 only, because this is a new value. This is not got from any of the previous value like f1 or f2. Okay, so that's why this is a new value and we will consider it as f3. Okay, so let us, same thing we will follow for f4, f5 and f6. Okay, so I'll write here directly f4. If you apply the formula, it becomes max of F4 is nothing but C4 plus F2 comma F3. So this is nothing but this is equal to max of what is C4? C4 value is 10 plus F2 value it's 5 comma what the value of F3 is 7. So this is 15 comma 7 out of this which is maximum 15. So 15 is a new value. We haven't got it from anything. So for example, here you can see 15. We got it from F2, but not only from F2, we got added by this C4. So that means it's a new value 15 and I will write it as F4. We got it as F4 because we haven't got it from any other value like previous one. Okay, then we have to calculate F5 also. So F5, if we calculate by using this recurrence relation, we will get it as max of C5 plus F3 comma F4. So this C5 is nothing but the cost of fourth coin, that is 10 plus F3. F3 we got it as, sorry, for C5 the cost is 6, sorry, the cost is 6, and F3 it is 7 comma F4 we got it as 15. So 6 plus 7 is 13 and this is 15. So that means the answer, maximum answer is 15. And how we got 15? We got it from fourth coin. You can see here directly we got it from fourth coin. So I will write it here. The maximum cost we got is 15 and directly we got it from F4 because no cost is added here. 15 we directly got it from F4. That's a maximum value. So I will write it as 15 then F4. So similarly, I will calculate F6 here. So F6 equal to max of C6 plus F4 comma F5. So this is equal to max of, so C6, what is the cost of 6.2 plus F4, its value is 15. So sorry, 2 plus 15 comma what is the cost of F5? F5 is 15. So out of this two, which is maximum? 17. So 17 is the maximum value, and 17 how we got? We just haven't got it from F4. For F4 something is added, that means it's a new value. So that's why I will write it as 17 and it is nothing but F5. So this is a new value because we haven't got it from any other coin. So that's why I will write it as F5. So this completes the solution. Okay, so I request all of you to write this recurrence relation and solve this like this. Okay, so let me erase and I'll tell you the later steps. Just a minute. Okay, right. So I'll write it once again. The table. So the table was index and then assets and then the cost which we found out from the recurrence relation. So index 0, 1, 2, 3, 4, 5, 6, and the asset values were, was given in the question. So 5, 1, 2, 10, 6, 2, and the cost we already have calculated. It was 0 and this is 5 and this was 5. We got it from F1 and this third coin it was 7. So we haven't got it from any other coin. So it was F3 and fourth coin it was F15 and we haven't got it from any other coin, so it is F4. Then fifth coin it is 15 and we got it from F4, and then sixth coin, the last coin cost was 17 and we haven't got it from any other value, that's why it is F6. Okay, right. So now this is the maximum value that we get once we pick the coin. So the maximum coin value is equal to 70. And now we need to understand by picking which coin we got 70. This was the actual question. Okay, so coin row problem is we have to pick the coin in such a way that we should not pick the adjacent coin, and we have to get the maximum value. So now we got the maximum value, that is 17. But now you have to backtrace, you have to backtrack or backtrace, and you have to find this 17 value, which is maximum one. We got it from which coins? Okay, right. So now let us see here. So how to backtrace? So from, you can see here, this 17 we got it from C5, that is fifth coin. Sorry, the cost of sixth coin, that is C6 plus F4. So we got this 17 value from this. So it indicates that once we added this C5 and F4, then we got the new value. That means C6, this is the mandatory, because only from F4 we haven't got maximum value. For F4, once we added C6, that is the cost of sixth coin, then we got the maximum value. So that means you have to keep this coin, sixth coin, because we got the maximum value once we added C6 and F4. So C6 is very important here. So that means sixth coin should be added or should be picked once we if we want to get the maximum value. So sixth coin we picked. Next, we have to go to fifth coin. So what's the value of fifth coin? It is 15. How we got 15 here? So it was if you go to the reconciliation, the reconciliation was for this fifth coin, it is C5 plus F3, F of 3, comma F4. Okay. So if you go to that reconciliation, C5 plus F3, its cost was 13 and F4 cost was 15. That means this maximum value 15, we directly got it from F4. We haven't got it from C5 plus F3. That means the cost of fifth coin is not mandatory here. You should not pick. If you pick, you will get it as 13, which is not a maximum value. That means this fifth coin you should reject. You should not pick it, because if you pick, you will not get maximum value. You will get it from F4. F4 is nothing but fourth coin. This is, we have to come here. Okay, so that means this coin is important for us. Fourth coin is very important for us. Now let us see what's this fourth coin. Fourth coin, we got it from which reconciliation? We got it from the reconciliation, that is max of C4 plus F2, comma F of 3. So we got it from this reconciliation, that is C4 plus F2 value was 15 there. So it was 10 plus 5, that is 15, and F3 value was 7. So here you can see maximum value, that is 15. We got it from coin 4 only. Once we add C4 and F2, then we got the maximum value. That means C4 is very important coin. We have to pick it. So after 6, we need to pick the fourth coin, because that is important. We got maximum value once we pick the fourth coin itself. Okay. So next, let us go to this third coin and let us check whether this is important or not. So the third coin, its cost is 7. How we got that 7? We got it from the reconciliation, that is max of C3 plus F of 1, comma F of 2. So what was the value of C3 plus F of 1? C3 plus F of 1, its value was 7. Then F of 2 value was 5. Okay, right. So C3 plus F of 1. So you now have to check whether to pick this coin or not. Okay. So once you just come here and check, even though we got the this coin, this cost, that is 7, once we pick the coin 3. Okay. But as the definition indicates that, as the definition or as the rule, you should not pick the adjacent coin. Already you picked the fourth coin. Already you picked the fourth coin. So even though you are getting maximum value for C3, okay, C3 plus F1, that doesn't mean that you need to pick the coin, because as per the problem definition, you should not pick the adjacent coin. So that means I will not pick this 3. I will directly go to this second coin. I'll directly go to second coin. Okay, this is very very important. So most of the people, they will get confusion that even see for this C3, once we calculate this cost of third coin, this is 2 plus 5, which is equal to 7, and this is 5. So out of this, 7 is maximum. How we got 7? We got 7 because of C3, and then they try to pick this C3, which is wrong, because as the definition indicates that we should not pick the adjacent coin. That means we should not pick the third one. We have to go to second one, and let us see whether we have to pick second one or not. Okay, so very important, please keep this in mind. Right, so let us see how we got this 5 here in for the coin, second coin. So second coin, the this recurrence relation was it is max of C2 plus f of 0 comma f of 1. So C2, the cost was 1, plus f of 0, it was 0, comma f of 1 is 5. So we got the maximum value 5 because of the first coin, not because of this C2. That means we should not pick C2. So don't pick it. Directly go and pick C1, because we got the maximum value, that is 5, because of this C1. That's why we should not pick C2. We have to pick first coin. So that means after 6 and 4, we have to pick 1. Okay, so once you pick one, that means there is no chance you need to pick, that is 0, because it is adjacent, and 0 means there is cost is also not involved, so that is rejected. So the total coin that we collected was first coin, fourth coin, and sixth coin to get this maximum value, that is 17. So you can see here, if I pick the first coin, its asset is 5. If I pick this fourth coin, it is 10, asset is 10. And if I pick the last coin, the asset is 2. So you can see here 5 plus 10 plus 2, you will get 17. So this is how you can cross verify the answer. So the coins picked are, it is 146. You can write it as 146 or 641. Okay, so that's the answer, and you can cross verify the answer like this. So this is how we need to understand, or we need to calculate for the dynamic program, or we need to apply the dynamic programming for coin row problem. So I hope this class, you have understand this technique in the online class, and I request you to solve this problem again to understand it in a better way. Okay, already I have given the recurrence relation also. You can take some different values and you can cross check with this. Okay, you can take different example for this, and you can apply this technique to cross check the dynamic programming technique. Now you can see one more thing is very important. See, you may ask me, sir, if you have said that we should not pick the adjacent coin. Suppose consider I have picked the first coin. I'll not pick 2. I will pick 3, because 3 is not adjacent to one first coin. Then if I pick 3, that means I should not pick 4. I should pick 5. So I will pick 5. So if you pick 5, then I will not pick sixth one. Okay, so that means I will pick 1, 3, and 5. Then what is our answer? You can see here, for if you pick the first coin, what is the cost? It is 5. If you pick the third coin, what is the asset? It is 2. Then if you pick the fifth coin, its asset is 6. So it is 5 plus 2, that is 7. 7 plus 6 is 13. You will not get any maximum value, because the maximum value that I can get is 17. So if you do like this also, you will get the wrong answer. Okay, so that like this also you can cross verify and you can answer this question. Okay, right. So let us see the algorithm for this coin change problem. Coin row problem. So I'll delete this. I'll open this file once again. Just a minute. Right. So the algorithm is very simple. So I'll write the name of algorithm as coin row. So coin row is the name of algorithm. And what is the input for this? Input for this is the array of coins from 1 to n. So I'll write it as a of 1, or you can write f of 1 to n. That is the coin, okay, array of coins. So now you know that if that means if n equal to 0, then what's the cost involved? F of 0, that is array of 0 is 0. Then if n is equal to 1, then the value of this is c1, that is the cost of first coin. Then uh, we need to apply the recurrence relation from second coin. So for I equal to 2, I less than or equal to n, because it will go up to n, then I plus plus. So what was your recurrence relation? It is max of uh, c of n plus f of n minus 2 plus, sorry, comma, f of n minus 1. So this recurrence relation will continue and the result will be stored in f of n. Okay, so according to the recurrence relation, I have written this equation. Then after executing all this, we have to return the f of n. So this is the algorithm. Okay, so the input is the row of coin along with the cost, and then this will be the output. So if you can go with the time complexity of this algorithm, you can see here. So for first coin, so it will take the linear time complexity, that is you can consider it as 1, and from it starts from the second coin up to n. So that means you have to calculate this recurrence relation up to n minus 2 coin. So n minus 2 means, so we have to go up to n minus 2. So that means it is nothing but it is nearly equal to n, because this minus 2 we will neglect it and we will call it as n. That means the time complexity of this algorithm is you can see linear order. Okay, it is linear order. So you can write it as big O of n, because once we if we pick the first and second coin, because we need to pick all the coins, so all the coins means it is big O of n, or else at least we need to pick n minus 2 coins. Consider we already have fixed the 0th coin and first coin value, then we need to calculate it from n, that is second coin till last coin, that is up to n. So total number of coins we picked is n minus 2, which is nearly equal to n. So you can write it like this also. Okay, so the algorithm order of growth is linear order of growth. So this is about coin row problem. So please go through it once again. So if you won't understand, we will discuss this problem in class. Okay, thank you.